All right, this is lesson 2.5, the applications portion of the unit. And we've done some of this already, so maybe these won't be as difficult as you think. I can use the relationships between angles to solve real-world problems. That's our goal. All right, so I think it's important when you look at a problem in geometry, you got to do a few things. So first, you've got to look at what's been given to you. You need to read the statement up here at the top. And you've got to pull in key words like bisect. That's pretty important right there. What does a bisect mean? Bisect means it cuts in half. So something got cut in half. Well, what got cut in half is angle EAH. So I'm going to go to my drawing, and I'm going to see AC here in the drawing cuts EAH in half. So these two angles are congruent. So I'm going to put single arc marks in there to indicate to me that those two are congruent. Well, then it tells me angle EAC is 2x plus 10, so I'm going to put 2x plus 10 in this one. And it tells me that CAH is 56. And then it tells me to find the value of x. Well, what's true about those two angles? In this case, we are taking those and we are setting them equal because of the bisector. So 2x plus 10 is going here. My 56 is going over here. I'm going to subtract the 10. It gives me 2x on the left. It gives me 46 on the right. Divide by 2. And I get 23 for the value of x. And for the first time, they actually just wanted x. They didn't want an angle. They could have asked for an angle, I suppose. But we already knew the angles in there. We could have asked for angle RAE. We don't know what that is. So they could have done that. All right. So what you want to do is ask yourself every time, are the angles equal? And in that case, it's because of maybe it's a bisector. Maybe they're vertical. And in both situations, the angles would be equal. Do they add up to 180? Well, you're going to see things like linear pair, or they might tell you they're supplementary. Okay. And do they add up to 90? Well, you might see a right angle mark, or they might say the word complementary. So those are the key words and things that you're looking for, in this problem and in the drawings, okay? One of these three models. So example 2, again, starting right off, what word did we see in the first sentence? Bisects. So AEAC bisects angle EAH. So again, I'm going to mark those two angles as being congruent. And then they tell me EAC is 2x plus 10. And they tell me CAH is 3x minus 7. And this time they say find the measure of angle EAC. So once again, bisect indicates to me that I'm going to set these two equal. So 2x plus 10 and 3x minus 7. It doesn't matter which one you put on the left or the right. It's going to be the same anyway. So there's nothing on the left or the right that can combine. So we're going to have to move the 2x over with the 3x, and I'll subtract 2x here and 2x here. It gives me 10, and 3x minus 2x is x minus 7. And add 7 there, add 7 there. And x is 17. Well, they didn't ask for x. They asked for EAC. So angle EAC is 2x plus 10. So 2 times 17 is 34. Plus 10 gives us a measure of 44 degrees for angle EAC. Okay? You guys give this one a try there. And pause the video, try it, and then see how you did. Okay? So for this one, hopefully you saw that these are vertical angles. So nothing else is really given to you. So you just need to look at the picture and say, I see what they're doing. They're vertical angles. It's the left and the right half of an x. So I'm going to set those two equal, right? so I got a 2x minus 15. I got a 5x minus 45. And nothing on the left combines, nothing on the right combines. But I need to move my 2x over with my 5x. So minus 2x. It leaves me with the negative 15. 5 minus 2 is 3x. And now add my 45. And I get 3x on the right and 30 on the left. And I divide by 3. And x is 10. Well, they want AXJ. Well, AXJ is 2x. Well, 2 times 10 then. Minus 15. So 2 times 10 is 20 minus 15. That's just 5 degrees. Really skinny little angle there. The pictures aren't always to scale. You can't guarantee that that's going to be the case. So you go by the math. You go by the numbers to determine those. So angle AXJ, well, what do you notice in the drawing this time? They didn't say very much, but I noticed that there's a pair that is linear. They form a straight line. So I know that makes 180. So I know that these are supplementary. Or maybe you recognize them as a linear pair. So what's our rule for that then? Well, it's blank plus blank equals 180. So we have an x minus 5, and we have a 4x plus 45. So on the left, we got an x and a 4x. Those make 5x. And I got a negative 5 and a 45. That makes a positive 40. Then I'll minus 40. 5x left on the left, 140 on the right, divide by 5. And x is 28. 248, yeah, I think so. But they want AXJ. Here's AXJ, x minus 5. So x is 28 minus 5 makes 23 degrees. Okay. So in that case, we had a supplementary pair or linear pair that we had to recognize. Example 5. 2 angles are supplementary. Well, that's pretty straightforward then. I'm going right to this. The first angle, so the second one's just plain old x. And the first one's twice that one. So it's 2x. So add 2x and x is 3x equals 180. Divide by 3, and x is 60. So the other angle is 180 minus 60, or 120. So my angles are 60 and 120. Very few words. And all I need is to recognize this mark means that those 2 angles are complementary, which means they add up to 90. So I know x plus 10 plus x plus 14 equals 90. So x and x, that's 2x. 10 and 14 is 24. So combining our like terms, subtract the 24. 80, 70, 66. Divide 2. And x is 33. So RAE is 33 plus 10, or 43 degrees. Oh boy. Lines AB and CD intersect at point X. AB CD X. The measure of AXC is 20 less than 3 times the measure of AXD. Well, the measure of AXD must just be X degrees then. And then the AXC is 20 less than 3 times that. So that would be 3 times X, and then 20 less than is minus 20. So those are my two expressions. And what's the relationship between the angles? Well, AXC and AXD in this drawing are a linear pair, which we also know to be supplementary, right? So I know that blank plus blank equals 180. So this is 3x minus 20, and this is just plain old x. So that gives me 4 x's on this side. Subtracting 20 gives me 160. Divided by 4 gives me 40. So there's one of my angles, 40, which makes this angle 40. And then 180 minus 40 is 140. So these angles are 140. So my drawing probably would have been better had I made AXC the skinnier angle and AXD the larger angle, or the skinnier one, but I didn't know, but it's okay. You go by the math, not by the drawing, right? Okay. Oh, it tells me AXJ is 56, but I already have something in that. It's already labeled 2x plus 4y. What's this other one equal to then? What do we know about those two labeled angles? Well, they look like a linear pair again, right? So we got this linear pair. So we know they're supplementary. They add up to 180, but how can I set this other one equal to something? If this angle here is 56, then angle JXS must be 180 minus 56, which is 70, 60, 51, 31, 24. So this is equal to 124. So now I have this series of two equations. And I'll rearrange them so the constant is on the right. Now I know this is asking a lot, but do you remember how to solve such a thing as that? Well, if you don't, just remember it's called a system of equations, and it's one of the next things we're going to study. So probably good to just get a refresher one here, and you won't have anything like this on the quiz or the test, but I just wanted to show it to you again to refresh your memory. So when you have a system of two equations that have two unknowns, so two equations and they each have an unknown of x and y in there, you have to eliminate either x or y. If you remember that term, eliminate, well, that means getting their coefficients to be opposites. Like if you look at this y, the opposite of 4y is negative 4y. So if I could just think of what to multiply this y by here to get it to be negative 4y, then it would eliminate the 4y up there. Well, that's simple. You just multiply by negative 4 and it'll become a negative 4y. But you need to multiply the entire equation by negative 4, not just that one term. So we're going to go 3x times negative 4 is negative 12x. And then y times negative 4 is negative 4y. And 124 times 4, I'm going to break out the calculator. 124 times 4, that's going to be a negative 496. And then the other equation I'll just copy down. I'm not going to change anything about that. And now you see negative 12x and 2x make negative 10x. And the negative 4y and the positive 4y cancel each other out. They are eliminated. Then I got a negative 496 plus 56. So I believe that's 440. Okay. And you divide by negative 10 and you get 44. So x is 44. And then to find y, you can just plug that back into one of the equations. Well, I'll take the second equation, 3 times x, which is 44. So I'm using this equation here. Plus y equals 124. Well, 3 times 44 is 132. And then I'm going to subtract 132 from 124. And I get a negative 8. And it's okay for y to be negative. It's not an angle measure. It just helps us determine the angle measure. So the values of x and y are 44 and negative 8. But you won't have to do one like that on the quiz or the test. But we're going to head into a chapter soon that has systems in it. So it's good to keep it fresh in your mind. I think this is the last one. Well, this one's got an x squared in it. So again, that's a unit that we probably won't see factoring and things like that with squares until Algebra 2 again. But let's keep it fresh in our brains here. So in geometry, though, what's going on here? Well, in geometry, this is a big X. So we get this large capital X in the figure, and these are opposite. The labels are opposite angles, and so that means they're vertical angles. So what I know about verticals is they're congruent. So I'm going to put my x squared on the left side, and I'm going to put the 13x minus 40 on the right, because to solve this one, we have to move everything to one side. This is called a quadratic equation because it's got an x squared. That's what makes this quadratic, not linear, which all the other ones we've been doing are linear. So in order to solve a quadratic, one of the methods is to factor. So in order to do that, we're going to move everything to one side. So the 13x jumps the equal sign and becomes negative 13x. And the negative 40 jumps and becomes a positive 40. And now I've got it equal to 0, which is how you solve quadratics. Now you can either use the quadratic formula, or you can complete the square, or you could factor. And what we're going to try and do is factor this. So we're thinking to ourselves, what can we multiply to give us x squared? Well, an x times an x gives us x squared. And then what could we multiply to get 40? Well, there's 1 times 40, and 2 times 20, and 3 doesn't work, and 4 times 10, and 5 times 8, and 6, and 7. So those are my only choices. But because this is just a plain old x squared, it's really fairly simple to come up with the right pair. The pair I need here is, when I add or subtract them, I need to be able to get negative 13x. And I think that's the 5 times the 8, right? So 5 times 8 makes 40. And negative 5 and negative 8 would make negative 13. So this would be a negative 5 and a negative 8, which would give me the negative 13 in the middle. So to get your answers, then, you just set each of these factors equal to 0 and solve. So you add 5 and you get positive 5 for x. You add 8, you get positive 8. So either 5 or 8 is the correct answer. So what that means is all possible measures of AXJ, well, they're going to be the same as KXS, right? Because they're vertical. It doesn't matter whether I plug the values into the 13x minus 40 if I simply square them. So 5 squared is 25 is one possible angle measure. And then 8 squared is 64, and that's the other possible angle measure. So those are the only 2 possibilities for the pair of angles here. Again, you're not going to have anything like that on the test or the quiz, but it's good to just keep it fresh in your brain as we head into Algebra 2 next year. So. All right, you've got an assignment informative. It's the lesson 2.5 applications, and that'll help prepare you for the test.